All right, thank you for coming, everyone. We might jump into this so that I can get started on time, because I'm going to max out every minute I have left in this talk. So I thought I'd talk about a bunch of stuff that I've been seeing in terms of the hacking scene, the data breach scene. A lot of stuff that's relevant now, but a lot of stuff I think is really useful for people to understand in the future. So I'm going to show you a few new things that I hope you can take away and use, and a bunch of stuff which I hope you find a little bit entertaining. So a lot of this is going to be about Have I Been Pwned? Who's used Have I Been Pwned before? All right, let's do this the easy way. Who's not used Have I Been Pwned? All right, so for the people who've not, in fact for everyone, if you want stickers later on, I've got a big stash of stickers here as well, so please come and grab some of those. If you have not used it before, Have I Been Pwned is a data breach aggregation service. So what that means is that when there's a data breach, the likes of, say, LinkedIn or Dropbox or one of these, and the data is spread out there around the web, I grab it, I load it into this system, and I make it searchable. So as of today, as of this morning, there's 8.5 billion records in there. About 18 of them are mine, unfortunately, because I have a Dropbox account and I have a LinkedIn account. There's a bunch in there that are probably yours. And the kind of scary thing is that there's a bunch more of all of ours which isn't in there. We just don't know where it is. Like, it's somewhere out there because there's all these breaches we don't even know about yet. And in all honesty, very often, the first that I know I'm in a data breach is when Have I Been Pwned sends me an email. It's always weird, right? It's like, oh, I just load all this data and it's, oh shit, I got an email from myself. This isn't good. Like, I had one the other day. I was in the House data breach. Anyone know what House is? I still don't even know exactly what it is, but I was in there because I created an account, because I've created hundreds and hundreds of accounts around the web over the years. So I started this almost 6 years ago now, back in 2013. And this was the launch tweet. It's like, hey, I've made this new thing. You go there, you chuck your email address in, it will tell you the data breaches you've been in. And my intentions were good. I thought, oh, this will be a bit of fun. Some of my mates will use it, they'll do good things. And people were kind of suspicious. They're like, oh, you're basically just going to harvest all their email addresses. And I always thought this was funny when I got emails like this, because I'm kicking this off with 155 million email addresses. It's like, how hard do you think I need to try to get more? Like, how much difference does it really make? So people sort of started with a level of suspicion. And then what happened is very quickly it got press, it got exposure, and it got big in ways I didn't expect it to. And it was only like a few weeks after launch it started being in like consumer news stories, like things my mum and dad would read. And that's what made it super, super big. And then as time went by, it just got bigger and bigger and bigger. It got like more press, more people were using it, more data breaches. And I sort of got to this point a couple of years ago where I was like, this has now reached heights I never expected. It's taken me to places I never expected. And for me, the moment where that really hit was when I ended up here, which is US Congress. So I got invited to go to Washington, D.C. And testify there. And it's quite funny when I got the invite, because I'm like, I'm Australian, don't you? Like, are you really sure you want me and my convict heritage to come and talk about data breaches? And they're like, yeah, it'll be fun. And they're actually very nice. Now, it was challenging for me on many levels, not least of which is that I really didn't have any clothes suitable for going to Congress. So I live on the Gold Coast. I usually dress like I live on the Gold Coast. I've dressed up for you today. So I literally had to buy every piece of clothing you see me wearing there. But as you can probably tell, I don't like taking things too seriously either. I don't want to take myself too seriously. So I was like, I need to get some good socks, right? I'll get some cool socks. So I ended up wearing these really cool socks. And they look like this. They say, for those about to code, we salute you. And I actually got these from Sophos because I tweeted beforehand. It's like, I'm going to go to Congress. It's a really big thing. Has anyone got some nice socks that you can give me? Because I just spent a lot of money on a suit. And for me, like the moment where I realized just how weird stuff have gotten as a result of this project was when I realized that you can now buy a stock photo of my socks from Shutterstock. $199 US dollars for a photo of my socks. So the point I'm trying to make here is that I have ended up in many places I did not expect as a result of running this service. And I'm already planning talks for next year when I'm going to be in other places I really didn't expect as a result of this. So there's a lot of material yet to come. So I want to talk about some of the things that I've been learning as I've gone through this, and particularly some industry commentary as well. And I thought, being back in Australia, a fun place to start would be here. Anyone here from CommBank? Ah, shit. So, I've got to put it delicately now, don't I? Recently, a thing happened with CommBank. So remember that whole Royal Commission thing that was happening here? And it's like, okay, the banks are under scrutiny. You know, there's a bit of shady stuff that's been happening over the years. We're going to have to be open and honest about it. And CommBank had to make a disclosure about an incident that had happened there. And what I find interesting and sort of relevant to this talk is to look at how broad the spectrum of data breaches is, or what constitutes a data breach. And CommBank had to disclose that they had lost some data from some customers. And the story went that apparently they're decommissioning a data center. And as part of the decommissioning of the data center, they had to destroy some customer records. Now, they put the customer records on a truck to go to the secure destruction facility. And I managed to find some file footage of the CommBank truck, which you can see just here. And anyway, so they put all the data on the truck, and it's a whole bunch of like tapes and drives and things like this. And they're driving the truck along. They're going to go to a secure destruction facility. You know, like the big crunching things for hard drives? So all the hard drives are going to go in there. Anyway, the CommBank truck is driving along. They might have put too much data on it. And some of the data did fall off the truck. Like, not metaphorically, but they were concerned that literally the data had fallen off the truck. And the statement that came out afterwards, KPMG audited them on this. And KPMG said forensic investigators hired to assess the breach retraced the route of the truck to determine if they could locate the drives along this route, but were unable to find any trace of them. And to me, I find this fascinating that we're in this era where we're talking about encryption and sophisticated cyber actors and things like this. And it's like, yes, also we have data falling off a truck. You know, like this is how broad this spectrum is at the moment. So in more sort of typical everyday data breach news, last year I had an incident with these guys. Or rather, these guys had an incident. They had a data breach. Does anyone use adult fan fiction? Okay, so first of all, not putting your hand up is the correct answer. Right? Now, how do we put it delicately? If you're not sure what this site is, the advertisement does give it away a little bit. If you're really into gay vampire romance, this is the place you go. Now, personally, I don't really care what you're into. It's a website, it's a forum, people discuss whatever they want. What I'm most interested in is that if they have a data breach, I want them to know about it, and I want all of you who didn't put your hands up to know about it as well, because if you're in there, you need to know about this. Not to protect your gay vampire romance stories alone, but because the passwords that people use here are the same as the passwords they use on their Gmail, on their banking, on their social. We know this because we have the data. We can look at it over and over again, like we know that this is a problem. So when someone sent me the data, 800 or 186,000 records I think it was, we'll see a tweet in a moment. I was like, all right, this is a lot of data. I verified that I was confident to a high degree of likelihood that the data had come from this service. Now, incidentally, the way I often do this is I'll go through all the email addresses out of a data breach. I can just regex them out, and I'll look for mailinator addresses. So mailinator is disposable email addresses. You can send an email to anything you want at mailinator.com, and then you go to mailinator.com and you put that alias in the box and it goes, here's the inbox, you can read the messages. So if I can go and grab, say, 3 random mailinator email addresses out of an alleged data breach, go here, go to the password reset page, put each one of them in, and each one of those email addresses receives an email to that box, to the public mailer box, then my confidence level goes way up. I don't need to log in, I don't need to reset the email, I don't need to do anything which would violate privacy. All I need to do is see that they received an email. So I did that, and I'm like, okay, it's just another day on the internet, it's another data breach. I'm going to send them an email. I'm going to let them know that I think they've had a data breach. So this is what I sent, and I found 2 published email addresses on their website, technical support at and forums at. And I said, hey, I'm Troy Hunt, here's a link to the thing. Here's some sample data, usernames and password hashes, because this is data that only someone who actually has their database should know. So this makes it very easy for them to verify that someone else has probably got their database. Now, this was the 19th of July. And days go by and I haven't heard from them. And the problem that I have time and time and time again is, what do I do when I don't hear anything from them? So I've got like a 6-figure number of people in there. I'm going to have subscribers in here. So there's about 3 million people subscribed to Have I Been Pwned, asking to be notified if they're found in a data breach. What do? They're not replying. So I go on Twitter and I say, hey, does anyone have a security contact at adultfanfiction.com? Now, as soon as I do that, everyone's like, oh shit, this isn't going to be good. Like, what's happened, right? And of course, no one did. Nothing happened. So 19th of July, I sent this. Fast forward nearly 3 weeks, 6th of August, I load the data, announce it in Have I Been Pwned. Names, dates of birth, because apparently you need that to read vampire porn. Email addresses, passwords stored in both MD5 and plain text. Is it to make it easier to upgrade the hashing algorithm later on? Like, why would you do this? I don't know. 79% of the people in adult fan fiction were already in Have I Been Pwned from other data breaches. I always publish the percent because I'm always fascinated by how many times people get pwned, like over and over and over again. So this goes up, and all of the Have I Been Pwned subscribers who intersect with the subscribers of their data breach get an email. And then everyone monitoring domains, if there's an alias on their domain. So if you work for a company and your company uses domain searches on Have I Been Pwned, and you're like jono@acmecore.com, and acmecore.com is subscribed, then whoever controls that domain gets an email letting them know that you are in this data breach. Just pro tip, don't use your work email address for stuff like this. They will work that stuff out. So anyway, this goes out, and then people start posting on their forum. They're like, hey, has there been a data breach? I got an email from Have I Been Pwned. It said I was in a data breach. Now, when I saw this, it's like, this to me is more verification, because it's someone who uses their service, who has then got an email from Have I Been Pwned saying, hey, you use their service and your data is now public. This is, for me, further verification. This is even more verification. Someone else going, yeah, I got one too. I was in there. Now, the moderators of the site saw things a bit differently. So, Demon Goddess chimes in. She's a head evil tech wench. I told you this thing gets really weird, right? Chimes in, says, no, it's not true. One would think that instead of scaring users, the companies would contact the site itself. And I'm like, I sent you an email to 2 email addresses 2.5 weeks ago. You didn't reply. And she sent me an email. She said, none of this data exists in my database. Sorry for late response. I've been working hellacious hours at my day job, Demon Goddess 061. And I got to admit, like I had a moment, I was like, what does Demon Goddess 061 do in a day job? Maybe she's like a high-powered lawyer in a suit or something like that, and then it just gets night and vampire. Anyway, so she sends that, and then it sends a totally separate email shortly afterwards and says, now that I've verified this doesn't exist in my database, it doesn't say how she verified it, I expect you to remove the site from your data breach website now, please. No. It's like, why? It's like, you've given me absolutely nothing for that. And I went back to her and I was like, here is the data. And you've got people on the forum and they're explaining, like, you have had a data breach. You need to own up to this and accept it. And the theme that you're going to see throughout this talk is that very often it's really, really hard to get a company just to go, okay, we acknowledge it's happened. Let's deal with it responsibly like adults rather than in this fashion here. So anyway, back on the forum, one of the other moderators chimed in. This is Bronx Wench. She's a mighty dragon wench. And it gets better from here, trust me. She chimes in and says, there's no gain in hacking us. We're not an e-commerce site. Now, this I always find interesting, this assumption that just because you don't hold money or credit cards, that you're not a target. You want to know what makes you a target? You're on the internet. That's it. Job done. That's the criteria. Stand up a brand new website. See how long it takes before you're getting scanned for vulnerabilities. If you're looking to terrify people into buying security software, I'm not sure exactly what security software I'm selling, but anyway, this is an extremely effective gambit. She goes on and says, I sell private workshops and courses, true. During these, you'll be offered the opportunity to purchase security packages to prevent data breach from impacting you. Now, I've just done a workshop and I have done a terrible job of selling security packages because no one bought one because I wasn't selling any. So I'm not quite sure how she drew that conclusion. And the last bit was kind of interesting because she said, perhaps we don't have high-priced lawyers who will take them to court. Still not sure for what. Or perhaps he thinks our members weren't reporting for publishing their data without permission. That's what I intend to do. You can't read this thread anymore because they deleted it, because they realized that they were wrong, that it was legitimate. But this is the sort of stuff I've got to deal with every time I do disclosures. Now, in fairness, this is sort of at the extreme end of a negative response. Usually it's companies like, oh, I really don't want to have to deal with this. How do we sugarcoat it? Maybe we can write an email to everyone and say we take your security seriously. Maybe we'll get off with that. But very often this is the way it pans out. And the thing that really frustrates me with this is that there's just not easy ways to do disclosure. And people find exposed data. And how do they let them know? How do you let the company know? Because people are worried about repercussions to them. They're worried the organisations won't take it seriously because stuff like this happens. Another example of this is LUAS, and LUAS is the Dublin rail system. Now this is what the LUAS website normally looks like. This is what it looked like in January. Not quite as nice. You were hacked, evidently. Some time ago, I wrote that you have a serious security hole, you didn't reply. The next time someone talks to you, press the reply button. Which, okay, we've got to kind of break this down in two parts. They shouldn't have done this, right? Like whoever found the serious security hole, however they found it, shouldn't have done this. That is very illegal. You start having much bigger problems in your life if you get caught doing that. But also, assuming that they did actually reach out to LUAS, they should have actually replied and said, actually, I don't like to have security holes, but if I do, I'd like to know about them rather than having my website defaced. I do question the motives of whoever did this because they went on and they did ask for some Bitcoin, which is not unusual. I'll publish all data and send emails to a user. Here's the Bitcoin address. So this was in Jan, and LUAS had to tweet, and they said, website was compromised. May take the day to resolve. That was the 3rd of January. A week later, the website looked like this. Another week later, the website looked like this. It's like you're actually going backwards somehow. I don't know how. So they were offline for weeks, and it's like the Dublin rail system. It's a major thing. And it kind of makes me wonder, like, how different would the outcome have been if they were able to receive a security report and actually handle it responsibly? And again, as I said, like, one of the problems here is how do we communicate to organisations that they do have a security incident? Because responsible organisations want to know about it. That brings me through to this. Has anyone seen security.txt before? All right, so there's like 5 hands in a room full of, I don't know, a couple of hundred people. Now, security.txt is totally awesome. Proposed standard which allows websites to define security policies. And it works like this. You put a text file in .well-known and you call it security.txt. That's it. I'm going to show you what mine looks like because I've got one on Have I Been Pwned. So if I jump over to my browser, this is what a security.txt file looks like. It's a text file. It's simple. Here's who to contact. I've got an email address. I've got a Twitter account there. I've got a public key so people can go and encrypt the contents of their communication if they find something sensitive. It's a really, really neat model, and it's been proposed by this guy, Ed Overflow. And what I love about it is the simplicity. I mean, there's a lot of things you can spend money on, security-wise. This is not really one of them. And big organisations are starting to adopt this. So Google has really extensively adopted it. I'm going to show you how I know this in a moment. And as you can see here, they're like, okay, here's our contact encryption acknowledgements, policies, hiring policy. They've also got a BountyCon address there as well because they offer bug bounties. Dropbox has one, which is good because Dropbox has been very hacked in the past, so they want to sort of make sure they do the right thing here. The BBC's got a big one. And if you're interested in actually seeing all the other websites out there, the big websites that use them, you can go to this website here. This is crawler.ninja. Now, crawler.ninja is a website created by Scott Helm. He's a mate of mine, another security guy. He often speaks at the NDC events as well. Some of you know him. And Scott runs this crawler where every single night he crawls the Alexa top 1 million websites and he looks at various aspects of their security profile. Now you can go over to security.ninja, open up the security.txt sites, and here's a list of the big organisations that are using it. This is out of the top 1 million. So there's a lot there that are now using it. And if I do a quick search for, I haven't even done this before, but .com.au, Google, so Google features heavily. Ozbargain uses one, Health Engine, Event Cinemas. These are great because they're just text files. And for me, as a security researcher, like if I find something like their data floating around and I go and find this file, it's like, okay, awesome, I know exactly who to talk to now. I did some training for a bank in Oz recently and showed them this. And they were like, this is awesome, we've got to go and do this. It's like, excellent, cool, I've done my good deed. They'll go and do this. And then I met up with them in a conference a few weeks later, and I was like, so how do you go with that security.txt? And they're like, oh, our lawyers don't like it. What? They said, yeah, the lawyers are worried that if we do that, people will try and hack us. So, oh, shit. It's like, have you looked at your logs lately? It's like, this is what happens. So honestly, I think the biggest barrier is getting that past the legal folks. But I'd love it if more people could try and adopt this because it's better for the organisation. It's certainly better for people like me as well. Okay. Something a little bit different, Magecart. Has anyone heard of Magecart before? All right, interesting. This will be new for most people. So Magecart is a collective of people who have been very, very good at stealing credit card data off websites. And we've seen some really big headlines in the last year from some really big names. So for example, BA. BA had 380,000 sets of payment data stolen. Now, just to be clear, when we talk about sets of payment details, this is the full card number, the expiry, the name on the card, the CVV, and all this stuff that you're not actually meant to store. So people see these headlines and they lose their minds. They're like, well, why was British Airways storing this data? Why did they have it there in the first place? You're meant to dispose of that CVV as soon as you verify the card. We've seen others as well. Ticketmaster. Ticketmaster had a big one. And what we're actually learning here is that the way Magecart are running these attacks is they're not stealing the data out of the database. They're actually stealing it at the time of entry into the form. I'm going to show you how that works in a moment. OXO, same thing. OXO does a whole bunch of like kitchen equipment in the US. Now, OXO, we can sort of deconstruct and have a look at how this happened. And it all began with one line of HTML here, embedding an external JavaScript file. Now this looks pretty benign. Whack a JavaScript file in here, it's off jscloud.com, static.js. Notice how they never call it stealyourcreditcards.js? It's always like really, really subtle, because if you look at it, it's like, it could be something very legitimate. Now the contents of the file is this. And as you can clearly see, what this does is it listens to events on form fields. And when there's an event on a form field, so when you actually move off a form field, it takes the contents of the form field and it sends it off to a Magecart server. So what I've done is just reconstructed the way this works so that you guys can see precisely what it looks like. So this is actually just a demo. So I've taken the OXO website, turned it into a demo, and if we jump into the source code and have a look, what we're going to see is down the end of the file, all the way down the end, which we'll eventually scroll to, there's a section here which loads evilcyberhacker.com. Again, they don't normally do this, like they're a lot more subtle. Magecart.js. So this is all it is. It's one tag. If you can get this one tag onto the website, you're able to snare everything that's entered into the website. Begs the question, how do you get the tag onto the website? Well, very often it's from things like a compromised CMS, publicly facing CMS, and there's an unpatched vulnerability. Or there's an admin who used the same password as they did on adult fanfiction. You know, something like that. So you get in via these ways. I'm going to show you another way in a moment. So we've got this JS file embedded here. So what happens next? If we go and open up the dev tools on the network tab, watch what happens as I start entering data here. So we'll go down to, let's take a great card number like that, tab off the field, and there's a request. Set a month. There's a request. Set a year, there's a request. And what happens if we actually drill down on this is we can see that it's sending data off to evilcyberhacker.com. It's generated a token which is consistent across each request, so you can tie each of the fields together. And then it says, hey, here's the host it came from. And then it goes on and says, hey, there's a field called this, and then this is the value that's in the field. So it's literally going field by field by field. Here's the data, send it off to some command and control server somewhere. Now we have everything that we can piece together, and we've got full card data. And it all begins with just one HTML tag. The thing about it, and the thing I want to show you now, is that this is also really, really easy to defend against using freely available tools. So, who here has used a content security policy before? Okay, everyone in my workshop, and then a very small number of other people. So, here's what we're going to do this time. Now, this page is exactly the same, except it has a CSP, and I'm going to show you what a CSP looks like. If we go to the dev tools and just reload this page, a CSP is nothing more than a response header. If we go down to here, here's my content security policy. Now, all it says is, I can load stuff from myself, I can load scripts from myself, I can run unsafe inline scripts, which are just like blocks of script and script tag. I can load styles from myself, I can have unsafe inline styles, so I can have like a style block, or I can have style attributes of HTML tags. I can load fonts from myself, and that is it. So that's all a CSP does. The cool thing is, though, is that when I put that CSP on, this CSP does not allow content to be loaded from any other host. Because when I look at things like script source, it says script source self. Now I can go through on script source, and I could have script source cdnjs.cloudflare.com, so I could load stuff from Cloudflare. I could have a script source of a Google Analytics because I use their tags. I could have a script source of App Insights because I use Application Insights in Azure. So I can load things from other places, but only the places that I explicitly specify. If anyone tries to load a script file into this web page from anywhere else, it's going to be blocked. And we can see that because if we scroll down on the dev tools a bit, there's going to be a red blocked request down here somewhere. So here it is. Magecart.js blocked by CSP. It was not loaded from evilcyberhacker.com. Like, how easy is that? One response header. All you've got to do is be clear about which external locations you can load different content types from. So this is super cool, and it stops the content from being loaded. But for me as a website operator, I don't want to just stop it from being loaded. I want to know when someone attempts to load it, because that might illustrate a vulnerability. It might illustrate someone's got access to my CMS. It might illustrate I've got a cross-site scripting risk. It might illustrate one of my downstream dependencies has been compromised. I'm going to show you that in a moment too. So I can go one step further, and I can go and actually add a reporting URI. So I'm going to go to another tab, reload this one, and show you what my CSP looks like now. So my CSP is basically the same thing. The only thing I've done differently is I've added a report URI. Now, report URI is the URI that the user agent should send violation reports to. So what you're going to see in a moment is that when the browser attempted to load that Magecart.js file from evilcyberhacker.com, the browser is automatically sending a report to this URI just here. Now, you'll see it says troyhunt.reporturi.com, and reporturi.com is a service that Scott Helm and I run together. So Scott did the crawler.ninja service. You can log a bunch of reports there for free, and then beyond that we've got commercial models. You can report to your own URI as well. It doesn't have to be ours, but that's the history of why that one's there. So what does that look like? Let's go down and have a look at that blocked request again. Okay, so here it is, magecart.js. You can see that that's blocked. You can also see just before that there was a request to a URL ending in enforce, and it went off to troyhunt.reporturi.com. This is the violation report. Now I can open up that violation report. We'll see that it's a post request, and then I can go down and actually expand it out and have a look at what is in this payload. So this is what you get from a CSP violation. You get the blocked URI. So this is the URI that someone attempted to load content from, evilcyberhacker.com. You get the document URI. So this is the address that's in the address bar at the moment. Now remember, you as a developer, you get this. So you can look at it and you can go, hey, my page at /checkout/CSP report attempted to load in a JavaScript file from evilcyberhacker.com. I'm going to go and have a look at why that's happening, because it probably shouldn't be. And again, like, this is totally free. You can go and start dropping this into your browser now, and it's supported by every single browser too, which makes it super, super cool. Now, CSP adoption rates are like single-digit percentages for the top 1 million websites. We know that from Scott's crawler.ninja, because this is one of the things he looks for every night. And I'd love to see these numbers go up more, because this stops attacks like that Magecart situation absolutely dead in their tracks. The Ticketmaster one was especially interesting because it wasn't a vulnerability anywhere in the Ticketmaster website itself. It wasn't a compromised CMS or bad login credentials or anything like that. It was because of this. And this is a chatbot. And what was happening here is they embedded the chatbot in their site, and then the chatbot got owned. And someone injected that malicious script into the chatbot. So think about the way we compose web applications today. We've got so many things embedded from so many different places, providing legitimate services like chatbot. But how well protected are you if that external dependency gets compromised? So CSP can help with that, because your CSP is going to say, hey, I'm allowed to load scripts and images and styles from inventor.com. That's fine, you can whitelist that. But then if someone compromises inventor.com and subsequently tries to load script from evilcyberhacker.com, it's going to be blocked. So CSPs, give them a go. They're super, super, super cool, and again, they're totally free. All right, back on security vulnerability side of things. I thought we'd talk a little bit about IoT. I've got a couple of IoT examples because it's amazing how much stuff we're putting internet in, and it's even more amazing how badly we're screwing it up, which is, to be honest, kind of the interesting bit. So this is a Nissan Leaf, and the Nissan Leaf is an electric vehicle. And it has a companion application. It looks like this. And I was running a workshop in Norway a few years ago, and we did this exercise, the same I did here in Sydney for those in my workshop, where what we do is we take the mobile device and we proxy the mobile device through PC or Mac and look at the traffic. And you can see all of the API requests from the app. And it's kind of fascinating because you get to learn how these apps are constructed. You get to see some of the dodgy stuff they're doing, and you get to see security vulnerabilities. So there's a guy in my workshop, and we did this exercise during the day, and that night he wanted to go and have a play with it. He wanted to see what he could find in his own apps. And he had one of these cars with the companion app. And I was kind of fascinated. I was like, why do you need a companion app for your car? Like, what is the purpose of this? And he said, well, what the companion app allows you to do is you can pull back the battery status of the car, so you can see that remotely. It also allows you to see the trip history, so you can see how much you've been traveling. And a really, really important thing for Norwegians, which I've since learned, is that it gets so cold in Norway, they have to be able to turn the heater on before they get into the car. Now, this is not a problem we have here, and I sort of do this talk in other places of the world, and people are really fascinated about how different Australia is. And I explain that in Australia, we don't worry about our cars getting too cold. We worry about incidents like this. This is real too, by the way. Different set of challenges. So anyway, he wants to know how his mobile app knows how to talk to his car. So when he tries to warm it up in the morning, how does it make sure it's his car that gets warm and not like his neighbour's car or someone in Sweden's car or something like this? And he's going, okay, so there must be some sort of a key, right? Like an auth token. Some sort of token that's stored in my device. A secret, of course, because if other people knew, you'd have a problem. So there's like a secret in my device, it's a key. I wonder what the key is. And he discovers that the key in his mobile app that controls his car is printed in the windscreen of his car. They use the VIN number. So Nissan literally used the VIN number to identify the car, which was amazing. And we saw this and we're like, surely this can't be right. Now, the VIN number has a combination of information about where the car was made, what year it was made, who the manufacturer is, And then it's got innumerable digits at the end. So you could take the digits at the end and just rotate them and find other cars. And I took this photo walking around Oslo, and it was like, that's my car, that's my car, that's my car, because now I've got what I need to actually control features of the car. So this was one of these incidents where, okay, we've got to disclose this. Like, we've got to let Nissan know, because this is actually serious. So I put out a tweet, does anyone have a security contact at Nissan? And again, everyone's like, oh, shit, this isn't going to be real good. And I did get a security contact. I got in touch with them, and they took it very seriously for a couple of days. And then I think they got a bit sick of me, because they're like, why does this Australian keep calling us up and bugging us? Like, all we want to do is like create cars and stuff. And they stopped replying to me. They'd completely lost interest. And this is a challenge, like as a security researcher as well, because it's like, okay, what do I do next? It's a little bit like the adult friend finder thing before, adult fanfiction thing. Adult friend finder was another website that had a data breach. Don't Google it here, go home. So what do I do? I started Googling around. This is like a month after I discovered this vulnerability. And I discovered that other people had found the same vulnerability, but they'd found it in a very different way. What people were saying is that the Nissan app is terrible. It's really, really slow, it's clunky. Now, what you do instead is that if you want to be laying in bed all cozy and warm and you want to turn on your heater in the car, what you do is you create a bookmark in your phone, one called Make Car Hot, one called Make Car Cold. And you take this URL and replace the VIN number with your own. Because it's much easier just to hit a bookmark. And yes, that does mean it's a GET request to change state. I know, it's upsetting, but this is what they did. So, when I saw that, I got back in touch with this and I sent them a link to this and I said, look, guys, other people have found this. Obviously, it is exploitable. I'm going to write about it. And they said, please don't. So I wrote about it. And the challenge is, it's like, how do I write about it and make sure that the gravity of the situation is conveyed? It's going to need to get some press because press puts pressure. Things happen once press is involved. But I don't want to overly sensationalize it either. And what I realized is that Scott actually had a Nissan Leaf. Just by pure coincidence, had a Nissan Leaf. So I said, all right, let's do this. We'll do a video. So I went home. This was in January a few years ago. I went home to the Gold Coast, and it's January on the Gold Coast. It's beautiful and sunny. Went and sat by my pool. Scott's in England, so he's miserable. And I said, all right, we'll do a little video. So this is a little video that shows a portion of what happened next. So look, what we want to do then is see what I can control from this end. And I guess the first thing is I can see that you got a big jacket on. It's cold there. Should we look at what we might be able to do with the heater, see if we can bring you up to Australia temps for a little bit? Okay, so what I'm going to do is I'm going to turn the heater on in his car from the other side of the world. And I'm going to do that by making a request to this URL. Now, this is that GET request I mentioned. That's Scott's VIN number. Feel free to take a photo before it goes off the screen. I'm going to make a GET request to this URL. And when I do that, it comes back with a JSON response. Now, one of the things you'll notice is that there is personally identifiable data in here. From that user ID, I can take a reasonable sort of guess as to whose car it is. And of course, because the VIN number is enumerable, think about what you could do with that. So, I hit the URL.
Beep in. Oh, there we go. Oh, my heated seats have come on. The air conditioning and the fans have just come on as well. You can see there's a status indicator on the dashboard to show that the car's currently being controlled remotely, which is now blinking. And I'm not sure if you can hear that, but all of the fans have come on full power. It's actually quite loud in here.
And that was it. I could turn the heater on the car. Now, that was part of a much longer video. And we put that online. And then you wouldn't believe it, suddenly Nissan decided it was actually important. Right? Like it just took that in order to get there. And they took the service down. I'm going to talk about what happened next in a moment, but I think it's worthwhile touching on what is the design decision that goes wrong here. Like, what's the assumption? So let's imagine a workflow here. We'll take Scott. Feel free to take a photo of that. Twitter handle's Scott_Helm. So anyway, here's Scott. And Scott is engaging with the mobile app. And the mobile app then talks to an API. Now, just to be clear, the API is not like hosted by the car. It's not like the car's running around with running IIS or something like that. So we've got an API sitting on a traditional web server. Then via a back channel, which in this case was a GSM network, it would then communicate with the car. Now, when we build apps like this, we get very focused on this relationship here, so the user with the application. This is what testers play with. This is what customers are engaging with. This is where all the focus tends to go. And we neglect this part of the relationship because this is behind the veneer of a rich client app. You can discover it easily enough, as we did. You just got to proxy your app and then you can see what's going on. But this bit gets missed time and time and time again, and this is where people make egregiously bad design decisions. You're going to see another one in just a moment. So if you're building mobile apps like this, make sure you really, really scrutinize those APIs, because people can deconstruct your app very, very quickly and see how it's calling the APIs. And you've got to assume that people call them in all sorts of ways that you never intended them to be. So Nissan took the app down. And of course, this meant there are a whole bunch of people in parts of the world who are now cold when they got into their car. And some people got quite upset about it. Now, when the app eventually went back up, it looked like this. And Scott sent me this screen cap, and he said, can you see anything unusual? And I kind of zoomed in a little bit and had a look at it. I went, that app explanation is rather unusual, isn't it? How does this happen? And I was perplexed. So we Googled it, and we found a Stack Overflow post like this. And there's an answer down here. And this answer includes the text, "The spirit of Stack Overflow is coders helping coders." So Nissan had copied and pasted this code and put it into their app. They never understood what it did. But it's even worse too, right? It's even worse, because what's that word? Spirit, yeah? What's the second word there? So they didn't even copy and paste. Like, someone just sat there and retyped it and, oh, this is a good answer, I'll just use this. They make cars, you know? This is not like adult fan fiction anymore. This is actual serious stuff. So obviously they were having a little bit of trouble, and it did keep it off a long time, and that did upset people. And one guy was so upset that he left a review on the Google Play Store. And he was particularly upset with me. He really didn't like this. And I saw this, I thought, well, you know, there's different ways I could react to this, admittedly. I think the way I'm going to react to this is I'm going to treat this as a reminder that people out there kind of need saving from themselves. Like, we need to be able to do this research and report this stuff. And as a reminder, I'm going to print this out and put it on my desk. So that's where it sits now. Now, this sort of pattern, this issue with having communication between rich clients or IoT clients and APIs, is something which keeps coming up time and time again. And I want to share another one from earlier this year. So this is TikTok Track. Now, they make children's tracking watches. And probably the best way to describe it is, you ever seen the movies, it's like there's a prisoner and they're out on parole and they've got to be tracked and they get like an ankle bracelet. This is an ankle bracelet for your child. And you just put it on their wrist. So the term that's often used is helicopter parents. So people say helicopter parents are parents who are always worried their children are going to be kidnapped and murdered or something like that. And they always want to know where the child is. And because we can now create very cheap devices with GPS tracking and 3G cards, we can create devices like this, and you can always know where your child is, and you know that they haven't been kidnapped or murdered. These have sprung up around the world, and particularly over the last few years, as the manufacturing has got cheaper and it's been more accessible, we've seen more and more of them. And a mate of mine in the UK runs a penetration testing firm. He's a guy called Ken Munro. And he actually does some really interesting talks. He's done TED Talks and things before. He's a fascinating guy. And a couple of years ago, they did research on a bunch of these watches and found that they were just terrible. And they did it in conjunction with the Norwegian Consumer Protection Council. And what they ended up doing is actually recommending to parents, don't get these because they're so full of holes. The US made similar recommendations. Germany banned them completely, and I'll tell you why later on, why they banned them. And then earlier this year, Ken contacted me and he said, look, there's another company selling these. It's called TikTok Track. They're in Australia. You're in Australia. Why don't you take a look into them? Get one of the watches. We'll test it. We'll see what we can find. So I went to their website, and I'm always curious, like when I go to a website, what impression can I get about their security posture? And when I went there and I saw the padlock, I knew everything would be okay. And actually the other thing was to see the second paragraph there. We take the security of your data seriously. You know when I normally see that? In an email saying, we just lost all your data. We take the security of your data seriously. It's like, well, which one is it? Make up your mind. So that, to me, was a bit of a red flag. The way they really heavily leaned on the Australianisms was a bit of a red flag as well. Custom built, securely hosted in Brisbane, Queensland. How many of you are sitting here going, well, geez, I'm glad it's in Queensland, you know? Like, now I know it's going to be all right. Now, in reality, the watch is a Chinese-made watch. No problems with that. I've got a Chinese-made watch. It's just got an Apple logo on it. The software development was done in Sri Lanka. I don't necessarily think there's a problem with that either, but the whole sort of leaning on Australia thing is a little bit disingenuous. So as I was looking around the website, I was looking at the way it works and who was behind it. It's a mum in Brisbane who thought it would be a good idea to track her kids. And I guess the point I'm trying to make here is it wasn't someone with like a technology background or an Infosec background. It was someone who wanted to solve a problem with a technology solution. So I'm reading the website and thinking, I reckon if you buy one of these and put it on your kid, you'd be absolutely mad. So I bought one and I put it on my kid. This is Al. Al's 6. This is my kid. And we wanted to actually demonstrate this with me being like a helicopter parent. So Al and I went online. I'm like, which watch do you want? And of course, she wants the pink one. So okay, we'll get you the pink one. You'll see it's called Gator. So Gator is the company that makes the hardware. Now, Gator sells these watches to different companies all over the world who then build all of the software on top of it. They build the APIs and they build the mobile apps. So we get this watch, we chuck it on Al, and we start looking at the way the watch and the mobile device are communicating to APIs over the internet. Same sort of thing as what we did with the Nissan. Now, one of the first things we find is that there's a GET request to an API that pulls back data about the family. This is how you retrieve a family. There's a number in the URL. And because Ken can count, Ken can hack. Change the number, get another family. That's it. Job done. It wasn't completely without authorization. The process went like this. Are you authenticated? Yes? Okay, cool, go for it. You know, you can have anyone now. So there is actually an authentication token that is sent in the request header. If you don't have the token, you can't make the request. But the token is never verified against the resource that you're trying to load. Now, a slightly tangential thing while I got the number on the screen. This did end up being a big thing in the press. It got a lot of news. One of the things reporters always want to know is how many Aussie families are impacted. It's always the question they ask. So they're speaking to the CEO and they say, you know, look, this is a serious thing. It's a big privacy issue. Can you tell us how many Aussie families were impacted by this data breach? And TikTok Track said, it's commercially sensitive, we can't tell you. And I'm going, I reckon I know. It's like, if it's commercially sensitive, don't put it in the frickin' URL. So anyway, you make this request and you get back a response like this. Comes back with the family. This is my data. Now, of course, it's just a number in the URL. You could keep changing the number. To make sure that we didn't access anyone else's personal data, we created 2 accounts. We authenticated with one number, and then we changed it to the other number. We pulled back the other account. So we didn't have to access anyone else's personal data in order to demonstrate the risk. So that was one of the APIs. It's another API that allows you to get a child with a post request. Just feels dirty, doesn't it? I know that's not the big issue here, but there's just a part of me which just... It's not hard. And then they pass the family ID in the request, but why don't you just put it in the URL? There's like Rastafarians in the audience here just twitching at this. So you make a GET request, you can pull back a child like this, pass a family ID, any family ID you like. You can relocate a child with a post request, which does feel better, lat and long down to a very, very specific number. And it's kind of like, it's weird for me because I'm going through this and you try to put yourself in the position of someone who would be malicious. And you're like, okay, so someone wants to steal my kid and they're going to update this data. And then I started going to these really dark places thinking about it. And I was like, if I was going to kidnap a child, I'd just take the watch off. And I'd leave it behind. Why would I need to actually leave the watch on the kid? Because it's obvious. And then I was like, no, I've got to stop thinking about all this stuff. So anyway, you could relocate the child. So we decided that's what we do. So this was in the holidays earlier this year. We send Al off to tennis camp. And I open up the mobile app. So this is what it looks like. And I can see on the mobile app, she's in Southport, she's at the tennis club, she's fine. I'm at home and I know she hasn't been kidnapped or murdered, which is, okay, I know she hasn't been kidnapped. The other bit, and again, why do I keep going to this dark place? Because you're trying to put yourself in the shoes of the other party. Anyway, so she's at the tennis club and then Ken dumped her in the ocean. Because he has control of the API. You can make the child appear wherever you want. You can make them appear somewhere they're not, or you can make them appear somewhere that you think that they should be, but they're actually somewhere different. And then it got worse, because the watch is also a telephone. The watch has a 3G card. Now, the reason it has a 3G card is so that if the child is in danger, the child can call you, or if you really want to call the child, you can do that. But it would be weird if anyone could call your child, wouldn't it? So you have to specify who the parent is. Now, there's an API for that. So you can see where this is going. So we sit Al in bed, and Ken calls this API to set one of his colleagues, a guy called Vangelis, as Al's parent. Now, Vangelis got a really thick accent. You're going to hear him in a moment. So Vangelis is now the parent. He's not meant to be, but because of the vulnerability in the API, Ken has made him the parent. So Vangelis then calls Al.
Hello, Al.
Hi, who are you?
I am Vangelis from the other part of the world.
And when I watched the video, I was like, holy shit, this feels scary. Like, this is, I mean, I was there. I've not staged it all either, amazingly. And I saw it, but it just felt super, super scary to have like a stranger call my kid. And the thing about it is that this was a difficult process to go through with disclosure as well. And the thing that was actually difficult about this, to their credit, they actually took the service down really quickly. But the thing that was difficult is they kept wanting to blame Ken and I. It was our fault for this. It was not our fault. It's your fault for building shoddy software and then never testing it. This is the most basic thing that anyone would test. And there were really weird things that sort of happened as part of the process. It was stuff like we would get contacts from journalists who say, look, we've got a statement from TikTok Track. We'd like to know how you guys would respond. And one of the statements said, we ask the media to treat this for what it is, a couple of hackers trying to make a name for themselves. And it's like, okay, so Ken has done TED Talks. I have been to Congress. It's like, Google us. We have names. Like, this isn't to make a name for us. So this is to try and do the right thing. And because Ken is such a nice guy, we're having this discussion about how many wheels of the bus we want to run over the CEO after we chuck her under it because of comments like that. But he says, no, look, let's just reach out to her and we'll check. You know, does she really, really stand by this comment? And when he got in touch with her, she said, look, I never made that comment. It's the PR company. So there's a PR company basically running offense to try and deflect the blame. And it sort of illustrates the challenge again, where it can just be so hard to get organisations to take these incidents seriously and deal with them responsibly. And I thought I'd give you one last example of this in a slightly different context, but it just illustrates the problem perfectly. This is a biometric padlock. And the value proposition of it is you don't need a key and you don't need a pin. You just need something you already have with you, which is your thumb. And there's a guy called the Lockpicking Lawyer. He's got a YouTube channel. And he does these really awesome physical penetration tests on padlocks. It's everything from breaking stuff like this, which you'll see in a moment, and bolt cutters on big locks. Like, how much effort does it take to break a lock? So he gets this padlock and he finds there's a screw on the side of the padlock. Now, this in and of itself is hilarious because undoing the screw does exactly what you think it does. It's like he undoes the screw and the lock falls apart, but that's not the best bit. The best bit, and this is just a perfect analogy for the challenge we have doing disclosure in Infosec as well, is he sends an email to the company because he's a responsible guy. I should let them know before I publish anything about it. He sends this email and he says, look, I got your padlock, I took out my screwdriver, I undid the screw, the padlock came apart. The company said, the lock is invincible to people who do not have a screwdriver. And that is that. All right. Hey, we've probably got like 5 minutes if people have got any questions. Anyone want to ask a question? Yes? So are the security text files on websites mostly in English or other languages? All the ones that I've been able to understand have been in English. It's a good question. I would imagine, and I haven't actually looked at the spec in terms of localization, but I would imagine they're going to be in the language of the website. If it's a multilingual website, it's a text file put in multiple languages. So yeah, you could do multiple languages. Yeah. The header. All right, good question. So the question is, if the attacker has the ability to put a tag on a page, do they not also have the ability to remove the content security policy? Most of the time, no. And the reason why is think about the different mechanisms which allows you to get that JavaScript file loaded. So the tag on the page, a vulnerable CMS. Now, what does a CMS let you do? A CMS generally lets you add content in the page. A CMS typically doesn't let you modify headers. You think about your marketing department. Imagine the marketing department has got access to update the page's contents. I really hope your marketing department doesn't have the ability to go and start modifying headers and things like this as well. That's kind of scary. Also, think about the other one there with the Ubuntu chatbot. That chatbot was an external dependency. Now, if that external dependency has content injected into it, there is no way in JavaScript to remove the header from the parent website. So it would have to be a different sort of attack. If someone just completely owned your site and could modify anything, yeah, they could take that away. Also, you're much more screwed because they can modify anything. Other questions? Yes? Good question. So the question there is, I might have blocked loading external JS files from another host, but could you not just write the JavaScript inline in a script block? So CSP treats that as what's called unsafe inline script. And by default, when you have a content security policy, you cannot have unsafe inline script. So you can't have a script block on a page. You also can't have a JavaScript event on a tag. So you can't have like, on click or on blur or something like that. So it's kind of like two ends of the extreme. Like at the moment with no CSP, it's just like YOLO, any script block I want. With a CSP, no script block. And there's two middle grounds. So what you can do is you can have a script block. You can take the hash of the script block and you can add the hash to the policy as a source, which means that this exact script block can run. And you can also have a nonce. So you can generate a number used once on the server. You can put that as a nonce attribute of the script tag and then add that to a source in the header. And then that will only allow what's in that script block to run. So have a bit of a Google about it. Scott's written a heap of stuff on CSP. I've got Pluralsight courses and things like that on it too. Last question. Yes? So when you're saying you disabled iframes. Disabled iframes what? Like in your browser? Yeah, that's going to break a lot of stuff because there's a lot of sites that use iframes. Even things like reCAPTCHA use iframes. And part of the reason I know this is one of the things you can do with the content security policy is declare child sources. And child sources are the different locations that an iframe can be embedded from. So if you look at the content security policy for Have I Been Pwned, like literally just load the page, dev tools, look at the header, you'll see that child sources are allowed from, I think it's like google.com or gstatic.com, because I have reCAPTCHA, and the way they do reCAPTCHA is they use an iframe and then they embed content into it. So if you're killing iframe in your browser, it's a little bit like killing cookies in your browser. A heap of stuff is going to break. All right, folks, we're out of time. If anyone wants stickers, I'm going to put a whole heap from up here, so come and grab some, and thank you for coming.